Now let's take up question number 31. Here it states that a company manufactures two types of novelty souvenir made of plywood. Souvenir of type A requires 5 minutes each for cutting and 10 minutes each for assembling. Souvenir of type B requires 8 minutes each for cutting and 8 minutes each for assembling. Given that total time for cutting is 3 hours 20 minutes and for assembling 4 hours. The profit for type A souvenir is rupees 100 each and for type B souvenir profit is rupees 120 each. How many souvenir of each type should the company manufacture in order to maximize the profit? Formulate the problem as a linear programming problem and solve it graphically. So this is a 4-marker question from the chapter of linear programming. So here we are given with this case. On basis of that, very first you need to focus how many types of souvenir of each type the company will manufacture to maximize its profit. So very first we will be considering here X and Y to be the number of units of type A and type B souvenir which the company will produce. Then I want you to focus on the time taken for these souvenirs cutting. So basically here when you consider the time for cutting, the type A souvenir is 5 minutes each and for type B souvenir it is 8 minutes each. And total time given for cutting is 3 hours and 20 minutes. 3 hours means 180 minutes plus 20 which gives me total 200 minutes is the time for cutting, where we can consider that X units of type A souvenir are manufactured and Y units of type B souvenirs are manufactured. So in every case we can consider 5x plus 8y will give me the total time of cutting for the souvenir, which will be definitely less than or equal to this total time which is 200 minutes. So here I get the first constraint which is 5x plus 8y less than or equal to 200. Next, talking about assembling. For type A souvenir, 10 minutes is required for assembling. For type B souvenir, 8 minutes is required for assembling. And has been stated that total time for assembling is 4 hours. That means in this case, if I produce X type A souvenir and Y type B souvenir, then time for assembling will be 10x plus 8y. This will be definitely less than or equal to the total time, which is 4 hours, that is 240 minutes. So here I get the second constraint, 10x plus 8y less than or equal to 240. Moreover, as we have considered here X and Y to be the number of units of type A and type B souvenir, that cannot be negative, but that can be possibly 0. So these are non-negative constraints that these number will be greater than or equal to 0. So we get here 4 constraints for this question, which is clearly equation number 1, 2, 3 and 4. So in this question, our main aim is maximization of the profit. As you can read here that profit for type A souvenir is 100 each and for type B it is 120 each. If I want to obtain the objective function which is of the profit, for X units of type A souvenir, the profit will be 100x. For Y units of type B souvenir, profit will be 120 into Y. So total profit will be 100x plus 120y. So that helps me out to formulate the objective function of the profit, that is Z equal to 100x plus 120y. I have to maximize this value of the profit. So now on basis of these constraints, now I will be drawing the graph because we have to solve this linear programming problem with the help of graph. Firstly, I'll be taking this time constraint, which is 5x plus 8y less than or equal to 200. I need here the equation 5x plus 8y equal to 200 and I'll be drawing the graph of that. So if you consider x as 0 in that equation, x will be 0, then y will be equal to 25, and if y is 0, x is equal to 40. So we get here the 2 points 0, 25, 40, 0. For this straight line, 5x plus 8y equal to 200. So this is the first straight line. Next, on basis of the second constraint, which is the assembling constraint, 10x plus 8y equal to less than or equal to 240, we need to plot here the straight line 10x plus 8y equal to 240. If you consider x as 0, y will be definitely equal to 30. If you consider y as 0, x will be equal to 24. So we get here the 2 points again, 0, 30, 24, 0, which gives me this straight line. So we have already considered these two straight lines. According to the given constraints, you can again observe these constraints. 5x plus 8y will be less than or equal to 200 and this will be also less than or equal to 200. Moreover, we have two non-negative constants x and y both greater than or equal to 0. So if I consider here this plane, x and y both will be greater than 0 in the first quadrant. So all the feasible region will lie in the first quadrant. Next, if I consider this point of origin in the inequality 5x plus 8y less than or equal to 200, that satisfies this inequality. That means origin will lie in the feasible region. So on the half side of this plane will be the required region. Next, if I consider this straight line 10x plus 8y equal to 240, and if I substitute x and y both as 0, that means I substitute origin in its inequality, which is 10x plus 8y less than or equal to 240, that satisfies. So origin will definitely lie on the half side of this plane. So the feasible region will be formed by these four corner points. Here we have this point of intersection of these two points also. You need to solve this equation to obtain that point of intersection, and on solving this you will definitely get your required point. So in this case, when you will further solve this, you will obtain here four corner points. One is origin, another one is this point A having coordinate 24, 0, and then we have point B, which is the point of intersection of these two straight lines 8, 20, point C having coordinate 0, 25. So the feasible region enclosed by these 4 points is the required region. So here this is the feasible region. I could write here feasible region enclosed by these 4 corner points A, B, C and O, where coordinates of A, B, C are clear from this, and coordinate of this origin O is 0, 0. So one by one we will be substituting these values in the objective function z, where z is the profit equal to 100x plus 120y. So here we have this objective function z and these corner points. On substituting x and y respectively, you obtain for corner point A objective function as 2400, for corner point B objective function is 3200, for point C it is 3000, and for origin it is 0. So we need to maximize the profit here, where you are getting the maximum value of z at this point B. So this is the case of the maximum profit. That means the maximum profit will be when the company will produce x units, that is 8 units of type A souvenir, and y units, that is 20 units of type B souvenir. So in this way we have obtained the required solution of this linear programming problem. So this was a 4-marker question, and in this question when you formulated all these 4 constants, in this step you will obtain complete 1 mark, and for obtaining this objective function you will obtain half mark. Further, by plotting the graph for these objective function and obtaining the required feasible region, you will get here another 1 mark, and after obtaining these 4 corner points, when you obtain the respective value of the objective function, here you get 1 mark, and after that you obtain the maximum value of z in this case, and you obtain the final answer, which is given in this case as this value. So here we have this as the answer. In this step you will obtain rest half mark. So you get total 4 marks for this question. I hope it is clear to you. Now let's proceed to our next question. Now let's take up question number 32, and as you can clearly see in this question we have choice in this question where both the choices are from the chapter vectors. So in the first choice it has been stated that A and B are 2 vectors which represent 2 adjacent sides of a parallelogram. Find unit vectors parallel to the diagonals of the parallelogram. So here you have to obtain unit vectors parallel to the diagonals of the parallelogram. And in the second choice, using vectors you have to find the area of triangle ABC with vertices A, B and C respectively. So in this case, very first we are proceeding with the first choice where A and B vectors are already given. So we have been given with vectors A and B, which are basically the sides of a parallelogram and adjacent sides of a parallelogram. So if I draw here a parallelogram where this is A vector and B vector, on basis of that you can easily get here this diagonal vector as A vector plus B vector and this diagonal vector as A vector minus B vector. So here we get 2 diagonal vectors. Let's consider these 2 diagonal vectors as D1 and D2. So the diagonals of this parallelogram will be d1 vector as a vector plus b vector and d2 vector as a vector minus b vector or b vector minus a vector. When we talk about the unit vector parallel to the diagonal vector, unit vector of, let's suppose, n vector can be given by n vector upon modulus of n vector. So taking that into consideration, very first I obtained here d1 vector by considering a vector plus b vector. So here if you take sum of these two a and b vector, 1 plus 2 you get here 3i cap, 2 plus 4 you get 6j cap, and 3 minus 5 you get minus 2k cap. So modulus of d1 vector will be 3 square plus 6 square plus minus 2 square and square root of that, and this simplifies to the value root 49, that is 7. So on basis of that, we can definitely obtain here the unit vector along d1 vector, which is given by plus minus d1 vector upon modulus of d1 vector, which is 3i cap plus 6j cap minus 2k cap whole upon 7. Similarly, you can obtain here d2 vector, but remember this could be obtained as a vector minus b vector or b vector minus a vector. So we will consider here both possibilities. So if I subtract a and b vector, I get this value. So I will be taking up here d2 vector as I cap plus 2j cap minus 8k cap, and modulus of d2 vector will be given by square root of 1 square plus 2 square plus 8 square, which is here 1 plus 4 plus 64, that is root 69. So we can clearly get here the unit vector along d2 vector, which is given by plus minus d2 vector upon modulus of d2 vector. So here we get the required answers for this question. The unit vector parallel to the first diagonal will be given as this, and unit vector parallel to the second diagonal will be given as this. So here in this manner we have obtained the required answer for this question, and it was a 4-marker question where when you obtained here d1 vector and d2 vector in this step, after drawing this diagram you get here 1 mark. After that, when you obtain here d1 vector and modulus of d1 vector, after simplification you get here another 1 mark, and you get here half mark for obtaining the unit vector. Next, when you simplify this value of d2 vector and get this modulus of d2 vector, in this step you will obtain half mark. And finally, for obtaining unit vector along d2 vector, you obtain another half mark, which gives you total 4 marks for this question. I hope it is clear to you. Now let's come to the choice given in the same question. In the choice, we are talking about finding the area using vectors. Here you need to obtain area of the triangle using vectors. Very first 3 vertices of the triangle are given to us in terms of coordinates. We need to represent them in terms of vectors. So if 3 vertices are provided, using that you can obtain the 3 sides, the vectors representing 3 sides of the triangle. So I have here these 3 points A, B and C. On basis of that, I am obtaining here AB vector and AC vector. So here for AB vector, you will be subtracting the coordinates of point B with point A. So you get here 2 minus 1, that is 1 I cap, then minus 1 minus 2, that is minus 3 j cap, 4 minus 3, that is k cap. In similar manner, for AC vector, I will be subtracting the coordinates of point A from the coordinates of point C. So 4 minus 1, I get here 3 I cap, 5 minus 2, 3 j cap, and minus 1 minus 3, that gives me minus 4 k cap. You are aware, whenever we talk about a triangle, using trigonometry, you can get the area of the triangle as half AB sine theta. But here we have to use vectors. AB sine theta can be represented as cross product of the vectors. So if I consider the 2 sides as AB and AC, cross product of the side AB and AC, and half of that will give me the required area of triangle. So in this case further, I can consider the formula for area of the triangle as half cross product of AB and AC vector, where this cross product can be obtained through this. Here I am obtaining the cross product, and that is coming out as this value. So here on solving this determinant, you will get the cross product of these 2 vectors, that is AB vector and AC vector. So how do we solve it? Here very first, you need to simplify this. In this case, you can clearly see I have here I cap into 12 minus 3, that is 12 minus 3 I cap. Next I have here minus j cap into, here I have minus 4 minus 3, that becomes minus 7, plus I have k cap into this value, that is 3 minus minus 9. 3 minus minus 9. And you can see this all simplifies to the value 9I cap plus 7j cap plus 12k cap. So that is the cross product of these two vectors. But here, in order to get the area of this triangle ABC, you need half of modulus of this cross product, because area is always positive. So here, to obtain this modulus, next, here I have modulus of cross product of these two vectors, which will be equal to square root of 9 square plus 7 square plus 12 square. And you can easily simplify this to get the required answer. So here you can simply say that the area of this triangle ABC will be given by half of modulus of the cross product of these two vectors, which simplifies to this value, and here you will be definitely getting this as half of square root of, this simplifies to the value 274, where you can further take 2 inside the root, it will give you 274 upon 4 within the roots, which simplifies to the value square root of 137 upon 2 square units. So here you get the required area of this triangle formed by the given 3 points A, B and C. So this was a 4-marker question where we have to use the vectors to obtain the required area of triangle formed by 3 given points. The step where you obtain AB vector representing side of a triangle, here you get 1 mark. Obtaining AC vector, here you get another 1 mark. For writing this correct formula of half of modulus of AB vector and AC vector, you get half mark. Then for obtaining AB vector cross AC vector, you get here 1 mark. And finally, for substituting this value of the modulus here and simplifying it, you get here the rest half mark for this question. So in this manner, you get the total 4 marks for this question. I hope this question is clear to you. So this was the last question of section C. Now we'll switch on to section D, having 6-marker questions.